Okay, so now we're going to we're going to look at sine and cosine as a function. So the first step, and we're going to learn how to graph these guys as well. So what we're going to do is have our unit circle handy, and we're going to fill in this chart. So we've got our unit circle handy. You might have it already filled out in front of you. I'm just going to kind of think about, oh my goodness, can you even see that? There it comes into focus. Okay, so I'm going to think about what this is. This is 0, pi over 2, pi over 2, pi, 3 pi over 2. Okay, so when x is 0, this is 0. This is the 0.10. This is the 0.01. This is -1, 0, and this is 0, -1. When x is 0, angle 0, the sine is the y value, and so that is 0. When x is pi over 2, the sine of pi over 2 is the y value, so that is a 1. When x is pi, the sine of pi is the y value, and that is 0. The sine of 3 pi over 2 is -1. And then the sine of 2 pi, which is coterminal with 0, is still 0. All right, so what we did was we traveled around the unit circle one time and got to here. Now we could put in more values. We could go around again and again, or we could have gone around this way. But what we're seeing is this is going to be a periodic function. Sine and cosine are periodic functions. So we're gonna just point plot these as if we had we're point plotting a graph that we never had seen before. Like if you have to point plot x squared. Like what if you weren't sure what this looked like? You would put in some values for x and you would see what the y were, and you would plot these points to see what's happening. That's what we're doing right here. So this is my x-axis and this is my y-axis, and this is for the graph sine x. Y is equal to the sine of x. So I picked these x values for us. Later, you'll know how to choose them for yourself. So this is 0. This is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. Now, of course, these are not the only x values you could have. There's an infinite amount of choices for x values that you could use, but these are convenient ones. They give out nice values for us to graph. For instance, if we were going to choose this, and I was going to point plot this, I would choose some x values that were easy for me to calculate, like 0. I know how to find the square root of 0 at 0. And then maybe 1. The square root of 1 is 1. And then I wouldn't do 2 because the square root of 2 is an irrational number that's difficult for me to figure out. I would skip to 4 because the square root of 4 is 2. And then I would go to 9 because it's a perfect square. The square root of 9 is 3. So I would pick nice values. So that's what I've done here for this trig graph is I've chosen nice values. You'll find that these values will produce x-intercepts and maxes and mins on this graph. And so I'm going to show you how to do that later. So we're just seeing what the sine function looks like. So when x is 0, which is here, it's 0. Let's call this 1, and let's call this -1. And when x is pi over 2, we're up here at 1. And when x is pi, we're at 0. And when x is 3 pi over 2, we're down here at -1. And when x is 2 pi, we're back at 0. So this is one cycle, one period of a, oops, I should have made that, of a sine wave. That's what a sine wave looks like. This goes on and on forever because the more we go around the circle, the more this will continue, and it would continue in the same pattern this way and this way. That's what it will do forever and ever. So this is a sine wave. We want to take note of a few things. What is the domain, the x values? Well, you can put any value you want to in here. So the domain is all real numbers, -infinity to +infinity. And the y values are limited between -1 as a low and 1 as a high. So the range is limited between -1 and 1. I put those in brackets because it's defined there. Now the period. The period is how long a graph will go until it starts to repeat. So we went from 0 to 2 pi, and then it started to repeat itself. So how long did it take to start to repeat? 2 pi. That's how long you had to travel. So the period is 2 pi. Technically speaking, this is going to be called 2 pi over b. We'll see that in a minute. The spacing. Now, the spacing is how I chose these values right here. So the spacing for all of our trig graphs will be whatever the period is divided by the value of divided by 4. So the period is 2 pi. So 2 pi divided by 4 is pi over 2. That's the spacing. That is why I said, let's go from 0 and then go 2 pi and then plus another 2 pi and then plus another 2 pi and then plus another 2 pi. That tells us how to put in nice x values, how to split up our x-axis. The amplitude is how high and low our graph, how high and low our graph will go from the midline. Now the midline is the middle of the graph. So for the basic graph, this is the basic graph, sine x, without any kind of stretches, shrinks, transformations of any kind. Y equals to the sine of x. The midline is y equals to 0, which is the x-axis. The amplitude is up 1, down 1. So the amplitude is 1. How can you see that from the graph? Well, this is y equals to a sine of bx, but we're looking at y is equal to the sine of x. What does that mean? That means that the value of a is 1 and that the value of b is 1. So the amplitude is whatever this a value is, but it's the absolute value, because it's just as a distance, how high and low is it going between the midline. And b is the number in front of x, and that affects the period. So technically, the period is not 2 pi, it is 2 pi divided by b. But because b is 1, for a normal sine graph, 2 pi divided by 1 would be 2 pi. That's why we say that. All right, let's look at the here's significance. Let's take note of the sine graph. The domain is everybody. The range is -1 to 1. And sine graph starts in the middle. This is where it starts. When it's at 0, it's at the middle. That's what we want to kind of take note of. All right, now let's look at the cosine. We're going to do the same thing. We are going to point plot. Here are nice values of x. Of course, there's an infinite amount of x's we could put in there, but let's just pick out the ones that are convenient, kind of like this was convenient. For angle 0, when I'm at angle 0, the cosine of 0 is the x value, and that's a 1. When I'm at pi over 2, the cosine of pi over 2 is the x value, and that's a 0. When I'm at pi, the cosine of pi is the x value, and that's a -1. The cosine of 3 pi over 2 is the x value, and that's another 0. The cosine of 2 pi is another 1. All right, so let's go through and let's plot these. Let's see, this is the y value, and this is the x value, and this is for the graph cosine of x. So this is 0. Here's, I'm going to divide up my x-axis. I'm going to divide this up into pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. Of course, it goes on, so I'll do it a little bit longer this time. Let's see. This will be 2 pi is really 4 pi over 2, so the next one would be a 5 pi over 2. 6 pi over 2 is called 3 pi. 7 pi over 2, and then 8 pi over 2 would be 4 pi. All right, and it goes on, but let's just do this. All right, ready? When x is 0, the cosine, this is a big 1, and this will be -1. The cosine is 1. All right. When x is pi over 2, which is this first one, it's at 0. When x is pi, which is the second one, we're down here at -1. When x is 3 pi over 2, we're here at 0. And when x is 2 pi, we're back here at 1. This is one cycle of a cosine graph. And it looks like that. Now, of course, it goes on and on. If we continued, 5 pi over 2 would hit 0. 3 pi would be down here at -1. This pattern will repeat. So it will do this. And it will keep going. All right. Forever and forever. All right. So the domain of cosine graph is also -infinity to infinity. The range is the same as sine. It's from -1 to 1. And the period is 2 pi. But this is without any transformations or any transformations whatsoever, reflections, whatever. So it's really technically 2 pi over b. But if we've got y is the cosine of x, b is 1. So this is really 2 pi over 1 or just 2 pi. And a, in this case, is also 1. So the amplitude, how high and low the cosine's going above the midline, is 1. The spacing is always whatever the period is divided by 4. So it's pi over 2. And so that told me how to mark up my x-axis to get the interesting points on this graph. The midline, which on your sheet, hopefully it's already been shifted over here, is the middle of the graph, which is at y equals 0. All right, so this is the basic cosine graph. What we want to sort of take note of for this guy is that it starts high. Cosine starts high. So it's like starts high. Oh, I can't spell. Height. High. H-I-G-H is what I'm trying to put right there. And sine starts in the middle. Starts in the middle. Starts in the middle. Okay, that's what we want to take note of. Now, here we go. We're going to graph a couple of basic graphs. 3. Sketch the graph of y equals to 3 cosine of 2x. So over this interval, -pi to pi. So we want to keep in mind that this is y is equal to a cosine of bx. All right, here we go. The value of a is 3, and the value of b is 2. All right. So the amplitude is equal to whatever the value of a is, the absolute value of that. That's how high and low it's going to toggle. So the amplitude for this graph is 3 because a is 3. All right. The period for cosine without any kind of anything is 2 pi. But it's 2 pi divided by b if b, whatever the b is. So if b is 1, it's just 2 pi. If b is not 1, it's going to be manipulated. So it's 2 pi divided by b. But we know that b is 2. So it's pi. The period for this graph is pi. That's how long it takes for it to cycle. The spacing is whatever we calculated the period to be, which is pi, divided by the number 4. So pi over 4. That's going to tell us how to mark up our graph. Is there a vertical shift? I think I have this marked out. You shouldn't even see that on your sheet by the time you get this. Is there a reflection? A reflection is indicated through a negative. So at this point, I'm going to take like a little side reminder of some things that you've seen before. So here's just a little bit of a reminder of what you saw in algebra. Suppose that we're looking at the absolute value of x, something, it's a V-shaped graph. And I chose this because it's easy to draw. This is what the absolute value graph looks like. It looks like about like this. So if they said, let's do some kind of transformations of these. If they said, I would like you to graph y is equal to negative the absolute value of x, then what that does is that flips it upside down. And that's what I'm referring to as a reflection. So we'll see a reflection if there's a negative in front of the A value on our trig graphs. Also, we will get into what if the value of A is not 1 on that? What's that going to do to our sine and cosine graph? That's going to make it shrink taller or squattier is what I'll say. So we have y is equal to 2 absolute value of x. This is like if I change the A value. What that's going to do is it's going to make the slope bigger. It's going to make this V kind of sharper. What if we have y is equal to 1/2 the absolute value of x? What would that do? That's going to make our slope lower. It's going to kind of make our graph a little squattier. Okay. So when I change these numbers in front, that can affect like how high and low, how I guess skinny or fat our graph is sort of. And the negative is a reflection. So we can see the same thing in our trig graph. So when we see this 3, this will affect it. Now, what not the problem, but what the issue here is that we're hand sketching it. So ours might not look as squatty as it really is. So I will show you a picture of what this looks like. I'll either call up Desmos or my graphing calculator and show you what that looks like so you can see what it looks like. But when we hand sketch it, we're choosing the scale of everything and it's not perfectly scaled. So it might not look exactly like that. That's okay, because as long as we label it, we'll get the gist. All right. So when it says, is there a reflection? I don't see a negative there, so I'll put none. Okay, the range. I'm going to do the range in a minute after I graph it in the midline. It's still going to be 0. Y is 0. Okay. The range, we can tell, since it's going to be up 3, down 3, so the range is going to be from -3 to 3. But we'll see that. We'll double check that after we graph it. So here's how we would graph one of these. You start by kind of filling out what's the period and what's the spacing and what's the amplitude. So I know that this guy's going to go up 1, 2, 3. It's going to go down 1, 2, 3. This is how high and low my guy's going to go. All right. Now, the spacing is pi over 4. That tells me how to chop up my x-axis. So this is pi over 4, and I know that because I'm labeling it that. Even though a minute ago I said that might be just pi over 2. And so plus another pi over 4 would put me here, and that's pi over 2. Plus another pi over 4 is 3 pi over 4. Plus another pi over 4 is pi. And so this particular graph said, okay, graph between negative pi and pi. So I got to go that far. And now I got to go the other way. Let's see. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. All right, ready? Once we know the pattern, this is a cosine graph. So I guess a minute ago when I first did these, there is a couple of things to note. Sine starts in the middle, but what is its pattern? It goes like this: middle, high, middle, low, middle. And then it repeats. Middle, high, middle, low, middle, high, middle, low, middle, high, middle, low. That's its pattern. Cosine is very similar, only it doesn't start in the middle, it starts high. His pattern is high, middle, low, middle, high. Middle, low, middle, high. That's its pattern. So here we go. We've labeled our amplitude, we've labeled our x-axis, and now we just got to know, where does cosine start? Cosine, it's a cosine graph, right? The 2x has been accounted for in the period and the spacing, so cosine starts high. So we're going to start here, and then we continue our pattern. High, middle, low, middle, high. This is one period of my cosine graph. If we want to go backwards, then it's going to continue backwards, right? I go in reverse, kind of middle, low, middle, high. Oops. And that is the graph of this. All right, I'm going to pause for just a second. Okay, so I have called up Desmos.com and then I put in this is showing sine of x. So this is what a regular sine wave looks like, just so you could see that. It's got an amplitude of 1, and so it goes up 1, down to -1. And so this is what the sine wave looks like. This is what cosine looks like. It looks the same, only it starts shifted a little bit. It starts high and then middle, then low, then middle, then high. So we graph those. Now, we just got through graphing 3 cosine of 2x. So I'm going to put that one on here. This is what it really looks like. We graphed ours on our paper and it doesn't really show the big effect. So what I want you to see here is that this 3 in front of the cosine is making go all the way up to 3 and all the way down to 3. And this 2 has cut the period from 2 pi to pi. So that means it's going to complete one cycle in pi. So this blue graph has changed the frequency, how often it completes a cycle, and the amplitude, how high and low it toggles. So even when we hand graph it, it won't look all that different, but we've labeled it so we know it's different. This is what it would look like if you used a electronic grapher, okay? So let me see. And we are about to graph 1/2 sine of 2 pi x. The 1/2 is going to affect the period. So this is a regular sine wave. The 1/2 in front of that's going to affect the amplitude. It's only going to go up half and down to -1/2. The 2 pi will affect the period. So let's see what that is really supposed to look like. Okay, when we graph the second one, ours is going to look about the same because we label our x-axis and our y-axis however we want it. But if you look at what this looks like on a grapher, it's only going to go up to 1/2 and down to -1/2. And instead of it taking 2 pi to complete a cycle, this one completes it right here, which is 2 pi divided by that b is 2 pi. It's only going to take 1 radian to complete it. So it's a lot more frequent. Instead of 2 pi, it's about 1/6 of what it only takes 1/6 of the amount of time to complete a cycle in this time. So even though when we graph it by hand, it doesn't show all the effects, we will know what's going on because of the labels, and you can get a feel for what's happening by using a graphing calculator or Desmos or something like that. Okay, let's do this last one. Let's go through this. They said to sketch this graph, and they said, I want you to graph it on this part of the x-axis. Okay. So the amplitude, this is y equals a sine of bx. All right, so the b is 2 pi, and the a is 1/2. So the amplitude is 1/2. The period is always 2 pi divided by b, but the b in this case is 2 pi. So the period is 1. All right. The spacing is going to be whatever we get for the period divided by 4. So it's 1/4. This shouldn't show up on your sheet. There is no reflection. There's no negative. Oh, so I should put none. I'm sorry. I should put none. Okay. And then the range, we can already tell what the range is. It's going to be -1/2 to 1/2 because it's going to toggle up and down. And the midline is y is 0. All right, so what we'll do here is we will label our x-axis. We want to split it up in 1/4. So we're going to go 1/4, 1/2, 3/4, 1. And we're supposed to go all the way to 2. So this is going to be plus another 1/4 is 5/4, 6/4, or 3/2, or 1/2, 7/4, 8/4 is 2. And then if we have to go backwards to -2, -1/4, -1/2, -3/4, -1, -1 1/4, negative 1.5, negative 1 3/4, negative 2. Okay, so that's what that one's going to be. All right. Negative 1/4, negative 1/2, negative 3/4, negative 5/4, negative 3/2, negative 7/4, negative 2. All right. So how high is it going to go? It's going to go 1/2 to negative 1/2 to negative 1/2. Okay. And so we're ready. We say, is this a sine or a cosine graph? This is a sine graph. Sine graphs start in the middle. So it's the middle, and then it's high. So by the time we get to 1/4, it's high, and then it's middle, and then it's low, and then it's middle, and then it's high, and then it's middle, and then it's low, and then it's middle. And then we can go backwards. Middle, high, middle, low, middle, like this. And so we can just copy down that pattern. Okay. And of course it goes on forever, but this is where they told me to graph it in between. And so that's not bad for a hand graph. And this tells, if at any point you're like, hey, did I mess something up? Is this, we can plug something in. So let's test something. Let's put in 1/2. Let's put in x is 1/2. Y is equal to 1/2 the sine of 2 pi, and x is 1/2 times 1/2. Well, 2 pi times 1/2 is 2 pi divided by 2. So this is 1/2 the sine of pi. But the sine of pi is the y value right there. It's 0. So this is a 0, and 0 times 1/2 is 0. So the output should be 0. So at 1/2, I should be at y is 0. So that checks out. Let's try something else. Let's try 7/4. Let's make sure we're in the right place. 1/2 the sine of 2 pi times 7/4. What is that? All right, well, 2 can go into 4 2 times. So we're looking at a 7 pi over 2, the sine of 7 pi over 2 times 1/2. All right, here's my unit circle. 7 pi over 2. Oh my goodness. This is 1 pi over 2, 2, 3, 4 pi over 2, 5, 6, 7 pi over 2 is coterminal with 3 pi over 2. And the y value is -1. So this is 1/2 times -1. So I should be at a -1/2 y value. So when I'm at 7 pi over 4, I should be down here at -1/2. And that's what I am. So you can always check to make sure that your points are landing in the correct places.